Hey everybody, in this video we are going to graph some more wild and crazy rational functions. This time we're going to do an example when m is less than n, and just to remind everybody about the instructions. So I went over them in the last video. This is my guide to graphing rational functions, made by me, copyright by me. Not really, but like, yeah, made by me. Yeah, it's my property. I think it's... yeah, you can't steal it without giving me credit. Yeah, it's my content. Anyway, the n behavior is going to be impacted when m is less than n. Then the n behavior is going to be approaching 0, and the reason for that will be elaborated on during the video when we get to that part. Okay. So here we have an example. If you hear snoring, this guy asleep. I keep moving my arm to stop him from snoring, but we'll see how it goes. All right, just like the other video, I would definitely suggest watching the other video first because I do elaborate on what the rules are, yada, yada, yada. But I do want to use the same colors consistently throughout. So well, let's actually start. This is already given to us. This is in expanded form. All right, that's expanded form for us right now. So the other form would be in factored form. If I factor that function, the numerator would factor with x and 3, x and 2, positive 1 in the middle, so plus and minus. On bottom, it's already partially factored, x plus 1, and then x squared minus 10x plus 25 will factor to x minus 5 twice, x minus 5, x minus 5. So I'm going to write it once and squared. So I'm going to start off with my x-intercepts, and we talked about this already, but to get the x-intercepts, what thing do I focus on? Well, for starters, I focus on factored form, and I focus on the numerator from factored form because that is what I set equal to 0 in order to set y equal to 0, and I want y equal to 0 when I'm looking for x-intercepts because every point on the x-axis has a y value of 0, right? So I'm going to set 0 product property, x plus 3 equals 0. That means x equals negative 3. X minus 2 equals 0. That means x equals 2. They both came from parentheses that were to the first power. This is also on my guide to graphing rational functions. And that means they both behave like a linear equation at those points. Let's go over to our graph. We got negative 3, linear behavior, and positive 2 with linear behavior. All right, boom. X-intercepts, killing it, crushing it, loving it. Next are the y-intercepts, which we use the green marker for. Y-intercept, and that one I looked more at expanded form. Now, here it's a little tricky. It's constant over constant, and the constant on bottom, in this case, you would get it right if you used a 25, but it's really the product of that 1 and 25, which is 25, but you would have to imagine it was fully expanded. So this is, I should fix this, semi-expanded. Clearly it's time for me to eat. Whenever I start really messing up, I know I'm hungry. Okay, so negative 6 over 25. So that's just like a negative number less than 0 but bigger than 1. I'm not going to go too crazy because it's usually enough information for me to do what I need to do. 0, comma, negative 6 over 25. It's about 1/4, give or take. Okay. Next, we're going to do the vertical asymptotes, which we did in pink before. Do you remember what we have to focus on for vertical asymptotes? Vertical asymptotes, we need to look at where the denominator is equal to 0. So then we also look at in factored form, denominator when that is equal to 0. So I will deal with the inside. X plus 1 equals 0 when x equals -1, and x minus 5 equals 0 when x equals 5. So -1 and x equals 3, 4, 5. Okay, so I can label that -1, 5. Now, unlike the last video, this time I have an even degree on one and an odd degree on another, just to remind everyone how that plays a role. Because if you were taught to test the intervals, plug in numbers, I'm sorry. I'm sorry. That's really unfortunate because it's really annoying. And nobody wants to do that. And this way, my way, the Delta Tango way, you don't have to do that. So if you look here at this guide, when the factor has an even multiplicity, the branches are either both pointing up or both pointing down. They're going in the same direction. So it's like end behavior polynomials. And when I just want to, sorry, I'm not very good at doing all this stuff. When the factor that the asymptotes came from is to an odd power, they're going to point in opposite directions, and you're going to base it off of any concrete piece you know for sure. If you mess up one piece, you're going to basically mess everything up, okay? Nobody wants you to do that. So let's carry on. We are going to now do one last component, and that is the horizontal. This is where I said I would elaborate. Horizontal asymptote or end behavior. Now, when we're dealing with end behavior, you're dealing with limits as x approach positive or negative and or negative infinity. So if I were going all the way to the right, for instance, you would say, what is the limit as x approaches infinity? So the limit is asking you, where is your y value going for this function f of x, whatever it is. So what would I pay attention to? The leading terms again. So I'm going to pay attention to leading term over leading term. All right, this is like my thought bubble of me doing this work. So what are my leading terms? They are x squared on top and x cubed on bottom. Let me elaborate. Leading term over leading term. So like the green, x squared over whatever x times x squared is, and that's x cubed. So what would, and if there were any coefficients other than 1, I would include that as well. Now I'm only going to pay attention to this because the more you go towards larger and larger numbers, the less significant like the x and the -6 become. And then anything I can create when I expand this, none of those numbers are going to matter. The x cubed is going to be growing so much faster and stronger than the rest of that polynomial in my denominator. This is all that matters. I'm going to reduce this. That leaves me with 1 over x. Now, if x is approaching infinity, what's happening? 1 over 10, 1 over 20, 1 over 30, 1 over 40, 1 over 50, 1 over 1 million, 2 million, 3 million. What's happening? That fraction's value is getting closer and closer and closer to 0. That will always happen when you're left with only x in the denominator. You're going to get closer and closer to 0, and the same will happen in the direction of the negative infinity. And sometimes, depending on what your top number is and all that, you can even tell if it's approaching it from under or from above. Are you going to get a positive or a negative answer as you approach 0? Yada, 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 because that could help you draw things later on. Okay, now we have everything we need. Oh, well, I never wrote. So here it's at y equals 0 for my asymptote right there. Okay. So let's buckle up. Let's go. I know in between these two asymptotes that this intercept is below the origin, connects to this x-intercept. This x-intercept is linear, so I'm slicing through pretty straight. But I can't come back down because I don't have another x-intercept, and I have to ride along my asymptote. Here, I have no choice but to go down. This is really kind of curved, it should be, smooth, curvy. And it has to go down because, again, I can't go up. I don't have x-intercepts. What am I going to do? Just stop? Can't stop. Linear again. Now this asymptote came from an odd power, odd multiplicity. So that means if the right side's pointing down, that's the side I know, then the left side's pointing up. Go there. Linear behavior, so we slice through, and then we're going to come around and approach our end behavior, because we said as we go towards negative infinity, the graph is going toward 0. All right, and then last but not least, this side, the 5, the vertical asymptote at x equals 5, really you should say x equals, that makes it an equation of a line. Even tells me that if this branch is pointing up, then this branch is also pointing up. And again, I'm approaching my end behavior of 0, and I don't have any more x-intercepts. Amazing, beautiful. There we go. That's everything. And if you were taught a silly, doofy, foolish way of testing intervals, I hope I changed your life. You're welcome. Now, let's just do the domain and range. So the domain are the x values from left to right. The only x values I'm excluding are where I have a vertical asymptote, so -1 and 5. So you're going to go negative infinity until -1. Parenthesis doesn't include it. Union picks up at the new part, 1 until, or -1, sorry, until 5. Parenthesis, I'm excluding the 5. Union starting right after the 5 until infinity. And the range, I got this cute, sweet squiggle that really encompasses every y value, so I can say my range is from negative infinity to infinity. If I only had branches like this, like I did with the reciprocal, then you might exclude something, but in this case I don't, and even I can't exclude the 0 because I even dipped right through it. See? Look at that. And that's it. You're welcome. I will do more of these a little bit later. I'm going to take a food break and puppy break. He needs attention, you know. And I'll be doing more examples. If there's a specific rational function that you want me to graph and you comment on it on this video before I sit down to do anything, just comment it to the best of your ability and I will make a video on that. Okay? Or if you're just a random person looking for math videos for your final exams and you need help with something, just comment it on one of these videos right here, so I could hopefully see it today and I can do my best to make you a solution. Thumbs up for puppies, thumbs down for puppy haters, and comment, question, concerns in the bottom. All the videos are linked in the description box. It's on a playlist. There's everything on my channel. I have so many videos of everything. Just search my channel. I'm sorry, I'm really tired. I need a snack. I need a meal. Bye.